Hello everyone, good day. Today I will demonstrate how to solve a system of linear equations with three variables using three different methods. So I will use GAUSS-JORDAN method, Cramer's rule, and of course, inverse method. So what is system of linear equation? So when we say system of linear equation, it is a set of equations that share the same variables. Since we have three variables, the x, y, and z, we need three equations to solve them. So the goal is to find the exact value of x, y, and z that satisfy all three equations simultaneously. Now, I will solve this system using all three methods to show that they produce the same solution. So I have here the given system. We have x plus y plus z is equal to 6. Next is 2x plus y plus z is equal to 9, and x plus 2y plus z is equal to 8. So first, let's solve this using the Gauss-Jordan method. But what is Gauss-Jordan method? So when we say Gauss-Jordan method, it transforms the system into an augmented matrix and applies row operations to turn it into reduced row echelon form. So the goal in Gauss-Jordan method is this. We have 1 0 0, 0 1 0, and 0 0 1. Now, we use three allowed row operations. First one is we are allowed to swap two rows. Next one is we allowed to multiply a row by a non-zero number. And third one is we are allowed to add or subtract a multiple of one row to another. So, here, our first step is to write the system into augmented matrix. So from this, we turn it like this. So now we have 1 1 1 6, 2 1 1 9, and 1 2 1 8. Now, for the next step is we need to eliminate entries below the first pivot, or we need to make zeros below the first pivot. So here, to get row 2, we need to deduct row 2 from 2 multiplied by row 1. So we have now the 1 1 1 6 and 0 negative 1 negative 1 negative 3 and 1 2 1 8. Now how did we do it? So we just simply multiply first the 2 to row 1, and after getting the answer, we need to deduct the row 2 to the answer of it. Okay? So the next one is to get the row 3, we need to deduct the row 3 minus row 1. So the final answer is 1 1 1 6, 0 negative 1 negative 1 negative 3, and 0 1 0 2. Now, for the next step is for us to make the second pivot 1. So to get the row 2, we need to multiply row 2 by negative 1. So it will become positive because that is our goal. Now, in this sense, our row 2 is equal to 0 1 1 3. Okay? So from negative, it turns into positive 1. Next step 4, is to eliminate column 2. Eliminate column 2. So, in order for us to eliminate the column 2, we need to minus row 3 from row 2. So, row 3 minus row 2 is this. Now, we have the 1 1 1 6, the 0 1 1 3, and 0 0 negative 1 negative 1. Okay? And next one is to get the row 1, we need to deduct the row 1 to row 2. So this is our final answer. For the next step 5, is we need to make the third pivot 1. So we need to multiply the row 3 into negative 1. Okay? So in multiplying row 3 to negative 1, here is the final answer. 1003, 0113, and 0011. Now, as you notice, we are almost there. But in second column, in the third row, there is a 1 and we need to make it into 0. That's why for step 6, we need to eliminate above third pivot. So we need to subtract the row 2 to row 3. So row 2 minus row 3 is equals to this. So we have this answer 1003, 010, So since we now have the goal that is to make this item like this, now our XYZ is found in this column, the fourth column. So our XYZ now is equal to 3, 2, 1. Okay? That is in their final reduced row echelon form, or RREF. So, for our next method, we have here the Cramer's rule. So, what is Cramer's rule? Basically, Cramer's rule uses determinants. So, attach here determinants, where determinant of coefficient matrix, determinants obtained by replacing the corresponding column with constants. So, it works only if determinant is not equal to 0. So, attached here is the formula of getting this x by z. So, for x, we have determinant x over d. And for y, we have determinant y over d. And for z, we need to have dz over d. So, in step 1, we need to find the determinant. So, we need to write this into its augmented matrix. So, from this, we have now the 1, 1, 1, 2, 1, 1, and 1, 2, 1. So, the next step is we need to expand this one. So, for our first part, this is our D. And we need to cancel or not going to write the first column and first row. That's why we now have 1 and we need to write the 4 numbers left, okay? So, we need to multiply the first number to the 4 numbers left. So, now we have 1 multiplied by 1, 1, and 2, 1. And we use the minus and plus, okay? We use the minus and plus operations. So, after that one, we also, in expanding this one, we need to have the first row and second column. We need to eliminate the first row and second column, okay? So, in eliminating this one, we need to write the C1, 2, okay? So, we need to subtract the 1 into 2, 1, and 1, 1, 1. So, and after that one, we need to use the operation addition. And the same process, we need to use the number 1 and multiplied it into the remaining numbers, okay? So, now we have 1, 2, 1, and 1, 2. Now, after this one, we need to cross multiply this item. So, in cross multiplying, first one, we have 1 multiplied by 1 and 1 multiplied by 2. In this moment, we need to use the subtraction operation. So, 1 multiplied by 1 is 1 and 1 multiplied by 2 is 2. Now, we need to deduct these items. So, now we have 1 minus 2 is equal to negative 1. Now, as you can see, there is a number outside this. So, we need to multiply the number 1 to the answer. So, now we have 1 multiplied by negative 1 and our answer is negative 1. The same process goes to other parts. Okay, so as to proceed, the same process belongs to the second one. So, again, we need to cross multiply these items. So we have 2 multiplied by 1 minus 1 multiplied by 1. So 2 multiplied by 1, we have 2, and 1 times 1 is equal to 1. Now 2 minus 1 is equal to 1, and now we need to multiply the outside number, which is negative 1. Again, you need to be aware of this, that to mm, you need to add also the sign, because if you don't add the sign, maybe you got the wrong answer. So always remember to include the sign. So now we will multiply negative 1 by our answer 1, and now we have negative 1. The same process goes to the third part, and our answer here is 3. Now we need to answer this, so we have negative 1 plus 3, and our d now is equal to 1. For the step 2, since we have now our determinant, for step 2, we need to find the dx. So, in finding the dx, we need to replace the first column with constant. Remember that our constant is the 6, 9, and 8. So since we are finding the dx, we need to replace the x part with its constants. So now we have here 6, 9, 8, 1, 1, 1, 1, and 2, 1. So the same process goes to this part. You just need to cross multiply, and after getting the answer, you need to multiply the answer into the outside number. So for dx, we have here 3. Now, since we have d, and in this part we have dx, the formula is to divide them. So dx divided by d is equal to 3. Our d is 1. We need to divide it to 1. So 3 divided by 1 is equal to 3. Now our x is equal to 3. For step 3, we need to find the y. So again, in order to find the y, we need to replace the the columns for y, with its constant. So we have 161, 291, and 181. The same process goes to these items. So you just need to cross multiply, and after getting the answer or the product, you need to multiply it to the outside number. So in this part, our dy is equal to 2. So dy divided by d is equal to 2 divided by 1, and our answer is 2. Now, our y is equal to 2. For step 4 is, of course, we need to find the dz. And in finding dz, we need to replace the third columns with its constants. So for dz, for replacing its third columns, we now have 116, 219, and 128. The same process goes to this item, and our dz now is equal to 1. Now dz divided by d is equal to 1. Now our z is equal to 1. So, as you can see, that is how we are going to do the Cramer's rule. Unfortunately for me, Cramer's rule is very easy method. That's why I love to do this. I love to have this method I really want to have this method because it's so easy and the process is very sabotable. Okay, so that is how we find the XYZ using the Cramer's rule. As you can see, we just have the same answer as we have as GAUSS-JORDAN method. But Cramer's rule is much easier. For third one, we have now the inverse method. So, in inverse method, we rewrite the system as ax is equal to b to solve x is equal to a negative 1b. So this works only if determinant is not equal to 0. So our first step is we need to write the matrices. So for this system, we now have A, X, and B. So what is A? So A is basically the coefficient matrix, X is a variable matrix, and B is a... Okay, so let's proceed. For step 2, we need to find the determinant of A. as we just did a while ago regarding with the Cramer's rule, let's apply the same process here. So again, we just need, for the first part, we just need to expand this one, and we need to eliminate the row 1 and column 1 and followed. So after getting the same process, you just need to cross multiply, and if you have the product, you need to multiply this answer to the outside number. So for determinant A, we have 1. So for step 3, we need to find the cofactor matrix. Now, in finding the cofactor matrix, take note that this Cij is equal to -1, I plus j, and Mij. So the sign pattern here is plus minus plus, minus plus minus, and plus minus plus. So when we say I, it is the row number, and j is a column number. Now, in finding the cofactor matrix, we just need to do this item. For Cij or C11, for row 1 and column number 1, we just need to eliminate the row 1 and column 1, okay? So in eliminating the row 1 and column 1, the remaining item is 1, 1, and 2, 1. Again, you just need to cross multiply this one, and you can get the C11, which is -1. For C12, the same. You just need to eliminate the row 1 and column 2. So, in eliminating the row 1 and column 2, you now have the 2, 1, and 1, 1. Cross multiplication, and you will get the C12, which is -1. The same process with C13, and in eliminating C13, we now have 2, 1, and 1, 2. Cross multiplication, now we have 2 multiplied by 2 is 4, and 1 multiplied by 1 is 1. 4 minus 1 is equal to 3. The same process goes with another item. So we have C21, C22, C23, and C31, C32, and C33. The same process. Now, for step 4, step 3, okay. For our next step, for step 4, we need to form the cofactor matrix. Again, as I said a while ago, in finding the form of co-matrix, you just need to multiply the minor plus the correct sign according to the checkboard, as I said a while ago. So, we now have -1, -1, 3, and 1, 0, -1, 0, 1, -1. So, that is our cofactor matrix. For step 5, you need to transpose to get the adjugate. So, in getting the adjugate, you just need to swap rows and columns. So, adjugate A is equal to -1, 1, 0, -1, 0, -1, and 3, -1, -1. For step 6, we just need to get the inverse of A. So, in getting the inverse of A, we just need to 1. And again, as we solve lately, the A is 1. So, now we have negative this item. So, for step 7, we need to multiply A -1 by B. So, you just need to copy and put the B here. So, our B is our constants, which is 6, 9, 8. So, you just need to distribute these items. We need to have row times column. So, in having row times column, you just need to multiply -1 by 6, 1 multiplied by 9, and 0 multiplied by 8. So, in multiplying these items, and after multiplying, you need to add these items, and now you can have your answer, which is 3. The same process goes with column 2 and 3, okay? Column and row 2, 3. Now, after having the answer, which is 3, 2, 1, we need to multiply 3 to 1 to 1 over 1. So, of course, multiplying these items will have the same number. So, for our final answer is 3 to 1. So, our x is 3, our y is 2, and our z is 1. So, that is the process on how to solve systems of linear equations using the Gauss-Jordan method, the Cramer's rule, and of course the inverse method. So I hope that you will learn something because I myself really learns a lot with this. So that's all for today and thank you. Anyways, I am Marjeline C. Lobo. God bless you.